They tell you Tesla wanted to transmit electricity without wires. Almost nobody tells you the physics he was actually using. Not radio waves bouncing through space, not beams shooting across the sky. The Earth itself is a conductor, the planet ringing like a bell at a specific frequency. A system so precise it could deliver power anywhere on the globe with mathematical accuracy. What did Tesla really understand about wireless power that we're only now beginning to prove with modern instruments? Altitude 6,000 feet. Tesla leaves his cramped Manhattan lab because he needs space. He needs thin air. He needs lightning. He arrives May 18th with two assistants, Fritz Lowenstein and Coleman Cito. They check into the Alta Vista Hotel, room 207. By June 1st, the laboratory is operational. 50 by 60 feet with an 80-foot ceiling inside. Outside, a conducting mast 142 feet tall, topped with a 30-inch copper-covered ball. The locals put up signs. Keep out. Great danger. At the door, someone posts a quote from Dante. Abandon hope, all ye who enter here. 500 pages. 200 drawings. Every experiment recorded between June 1st, 1899 and January 7th, 1900. He's not playing with sparks. He's measuring the Earth. The Earth contains stationary waves. He injects high voltage current into the ground at specific frequencies and watches the response. The whole planet behaves like a smoothly polished conductor with its own set of resonant frequencies. Think of it like this. Strike the Earth mechanically in an earthquake, it vibrates like a bell, period measured in hours. Strike it electrically, the charge oscillates approximately 12 times per second. But use the right wavelength, something directly related to the planet's diameter, and you can throw the globe into resonant vibration. Stationary waves form. Nodes and antinodes appear with mathematical precision. If you value documented electrical engineering and physics history like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from the Colorado Springs notes published by the Nikola Tesla Museum in Belgrade in 1978, the IEEE paper on Tesla and wireless energy transmission by Aleksandar Marincic from 1986, and Mark Cypher's biography Wizard, published in 1998 based on Tesla's personal archives. Now back to the information. 53 years later, in 1952, physicist Winfried Otto Schumann at the Technical University of Munich will calculate it mathematically. His students work out approximately 10 Hertz for the cavity between Earth's surface and ionosphere. In 1954, Schumann and H.L. Koenig measure it, 7.83 Hertz fundamental frequency, the Schumann resonance. Tesla was directionally correct about a planetary frequency decades before the tools existed to measure it precisely. He understood the Earth ionosphere system forms a resonant cavity. The utilities generator fails from the induced high-frequency currents jumping through the windings, destroying insulation. Tesla later writes about it in The Electrical Experimenter in August 1917. He's not apologizing. He's proving a point. His oscillations can affect electrical systems miles away through ground conduction. On stormy nights, his receivers pick up signals he believes might be from another planet. He reports this in letters to Julian Hawthorne on December 8, 1899, and to the Red Cross Society in December 1900. Whether it's lightning, Marconi's European experiment starting in July 1899, or something else, Tesla is detecting electromagnetic phenomena at extreme distances. His equipment is sensitive enough to measure perturbations in the Earth's electrical state. January 7, 1900. Tesla makes his final diary entry in Colorado Springs. He's proven to himself that wireless power transmission through the Earth is feasible. He returns to New York with a plan: build the first real power transmission station, make it operational. Expand to a global network of 30 towers. He needs money. Morgan thinks he's funding a transatlantic wireless telegraph to compete with Marconi. Tesla thinks he's building the first node of a world power system. The contract is signed. Construction begins. The area is being developed as Wardenclyffe-on-Sound, a resort community. Warden expects Tesla will eventually employ 2,000 to 2,500 people. Housing will go up on surrounding land. Tesla hires architect Stanford White of the prestigious firm McKim, Mead & White to design the facility. White is Tesla's friend. He's also the architect behind Madison Square Garden and the Washington Square Arch. He understands grandeur. A red brick laboratory building. Behind it, a wooden tower 187 feet tall. Some sources say 186. At the top, a 68-foot diameter hemispherical cupola, weighing 55 tons, made of steel, though some accounts suggest copper for better conductivity. The cupola has a 5-foot hole at its peak. Biographer John J. O'Neill notes this detail. Ultraviolet lights were planned for that opening, possibly to ionize a conducting path through the atmosphere. To get a grip on the Earth, you need deep contact. a shaft approximately 10 by 12 feet, going down 120 feet. Timber-lined, then steel, with intricate networks of iron rods and copper plates radiating outward into the ground. These aren't simple grounding stakes. They're designed to couple the facility to the planet's electrical properties. Some descriptions mention earth grippers extending through tunnels. Mark Cypher documents these in his biography, but admits Tesla never wrote extensively about them beyond brief mentions. The power source is a 200 kilowatt coal-fired Westinghouse alternating current generator. Not massive by industrial standards, but substantial for experimental work. Tesla plans to operate across a wide frequency range, from around 1,000 Hz up to 100,000 Hz or more, depending on the specific transmission mode. The goal is to establish resonance with the Earth's natural electrical oscillations, while superimposing higher frequency signals for communication. Construction starts September 1901. Immediately, there are problems: money. Tesla underestimated costs, materials are expensive. The stock market panic of 1901, which Morgan helped trigger through financial maneuvering, drives prices higher. Morgan still owes Tesla part of the original $150,000. Tesla writes letters to White complaining he's facing foreclosure before the facility is even complete. He's pouring his own funds into the project, everything he has. Marconi announces he's transmitted a wireless signal across the Atlantic. The Morse code letter S ... From England to Newfoundland. It's not sophisticated, but it's functional and it's cheap. Marconi is using some of Tesla's patents, 17 of them according to Tesla's count, but Marconi has commercial success. Investors start flowing toward Marconi. Morgan starts questioning Tesla's approach. Morgan replies through his secretary, will not provide additional funding. But Tesla doesn't stop. He continues construction through 1902. The building is finished, the tower goes up. The Wardenclyffe Tower comes alive. Bright flashes. Blue crackling arcs shooting up into the night sky. The light show is visible for 100 miles. Reports come in from Connecticut. Thunder that can be heard 15 miles away. Electrified butterflies. Sparks on horse hooves and water pipes. The atmospheric effects are spectacular. Tesla tells questioning reporters they've been sending wireless messages and power for some time. He gives no details about the July display. No explanation. Behind the scenes, the situation is collapsing. Morgan has made his position clear. No more money. Wall Street investors avoid the project because if Morgan abandoned it, something must be wrong. The rich man's panic continues affecting capital availability. Some funding comes from Thomas Fortune Ryan, but it goes to debt service, not new construction. The facility sits increasingly idle. He tries to interest the United States Navy in his remote control torpedo technology. No takers. He advertises Wardenclyffe's services. Almost no response. By 1906, the project is effectively dead. Workers have left. White is distracted by personal scandals that will end with his murder in 1906. Tesla himself appears to suffer a breakdown. 1908, another mortgage for additional expenses. 1915, his backers demand returns on investment. He can't provide answers. The banks foreclose. 1917, the tower is demolished for scrap to pay debts during World War I. Some conspiracy theories claim German spies used it as a transmitter or that the government ordered it destroyed. The simpler truth is debt collection. Wardenclyffe becomes industrial property, leased to a photo products company. The red brick laboratory remains. It's the only Tesla laboratory building still standing. System of transmission of electrical energy, patent 685956. Apparatus for utilizing effects transmitted through natural media. Granted, November 5th, 1901. And others. The full technical specifications. Tesla believed he could use the Earth as a conductor for low-frequency waves and the ionosphere for higher-frequency transmission. Two modes working together. The ground current mode involved injecting electrical oscillations into the planet at frequencies related to its diameter. When you match the resonant frequency, stationary waves establish between the injection point and the antipodal point on the opposite side of Earth. Energy travels through the planet as longitudinal waves in the telluric currents. A receiver tuned to the same frequency anywhere on Earth can extract power from these standing waves. His numbers were in the right range, even if not precisely 7.83 Hz. By exciting this cavity with the right frequency impulses, you create electromagnetic standing waves that circle the globe. A resonant receiver can capture this energy. The key term is resonance. Everything must be precisely tuned. Where Tesla's system fails is in practical implementation. Energy losses. As you propagate power through lossy media like soil and air, ohmic resistance converts electrical energy to heat. The Earth isn't a perfect conductor, neither is the ionosphere. At the distances Tesla envisioned thousands of miles, the losses become prohibitive. Modern measurements show the Schumann cavity has a quality factor between 3 and 12. That's substantial damping. Power sent into the system dissipates quickly. To maintain standing waves across the planet, you'd need enormous input power. The 200 kilowatt generator at Wardenclyffe wouldn't come close. You'd need megawatts or more. And then there's the receiver problem. Every receiving station extracts energy from the standing wave field. Add more receivers, each pulling power, and the system efficiency drops further. The energy has to come from somewhere. Tesla imagined free energy broadcast globally, but physics says someone still pays the generation cost plus all the transmission losses. To establish the necessary field strengths for useful power transfer, you're creating intense electromagnetic fields. Biological effects, interference with existing radio communications, navigation systems. Modern wireless devices operate in completely different frequency bands specifically to avoid these issues. A high-power, extremely low-frequency system would interfere with everything. The infrastructure for wired electrical distribution was already rolling out in the early 1900s. Alternating current transmission lines based on Tesla's polyphase systems. These worked. They were understood. They had clear business models. You could meter power consumption. Wireless transmission makes it nearly impossible to charge customers. How do you prevent anyone with a tuned receiver from pulling power without paying? Morgan understood this immediately. No profit model. A team at Massachusetts Institute of Technology, led by assistant professor Marin Soljakic, publishes results in the journal Science. They demonstrate wireless power transfer using resonant magnetic coupling. 2 copper coils tuned to resonate at the same frequency, approximately 10 megahertz. They successfully transferred 60 watts of power over 2 meters, approximately 6.5 feet. Efficiency above 40%, reaching 90% in some configurations. This work leads directly to the founding of Witricity Corporation. The MIT approach uses magnetic resonance, not earth conduction. The physics is different from Tesla's plan, but the principle is similar. Matching resonant frequencies allows efficient energy coupling over distances larger than the coil dimensions. It's near-field coupling, not radiative transmission. The magnetic fields don't propagate as radio waves into space. They decay rapidly with distance, which limits range, but also limits interference and makes the system safer. By 2014, Witricity technology is transferring power across several meters with efficiency exceeding 90% for certain applications. Consumer products start appearing. Dell launches the Latitude 7285 laptop in 2017 with wireless charging based on this technology. BMW 530e iPerformance in 2018 becomes the first production vehicle with factory-installed wireless charging. The 2022 Hyundai Genesis GV60 uses Witricity hardware. Electric vehicle charging stations can deliver 3.6 to 11 kilowatts wirelessly through cement, asphalt, or other materials. Over 1,000 patents and patent applications related to wireless charging. The Chinese National Standard for Electric Vehicle Wireless Charging, published in May 2020, incorporates Witricity technology. SAE International's J2954 standard for wireless power transfer includes their work. Major automakers including Toyota, Audi, MAHLE, Mitsubishi, Honda, Hyundai partner on development projects. By 2018, Witricity has agreements with 9 of the world's 10 largest automotive companies. Wireless helmet charging for soldiers with night vision equipment during vehicle transport. Industrial robotics, charging systems for automated guided vehicles and warehouse robots. The market for wireless power systems reaches $8.5 billion by 2018 according to IHS Technology, driven by consumer electronics adoption. Watts to kilowatts, not the megawatts needed for citywide distribution. Magnetic resonance wireless power is real and commercially viable for short to mid-range applications. It's not Tesla's world wireless system. That vision remains physically impractical. The losses are too high. The interference too severe, the business model too unclear. The power receiver. Array demo transmits over 800 watts over 8.6 kilometers, approximately 5.3 miles, using a fiber optic-based laser system. 30-second transmission duration, over 1 megajoule total energy transferred. Previous records were 230 watts at 1.7 kilometers for 25 seconds, and unspecified lower power at 3.7 kilometers. The DARPA system uses specialized photovoltaic cells optimized for narrow wavelength laser light. Very high conversion efficiency. The laser beam is tightly focused, requiring precise pointing and tracking systems. But it proves wireless power transfer over significant distances is possible with modern technology, just using completely different physics than Tesla employed. It's practical for specific applications like powering drones or remote sensors, where running cables is impossible. What did Tesla actually understand that was genius? the Earth as an electrical system. He recognized the planet and its atmosphere form a coupled electromagnetic environment with measurable properties. He understood resonance could amplify energy transfer if you matched natural frequencies. He grasped that tuned circuits at transmitter and receiver could exchange energy efficiently. These insights were decades ahead. His era was in extrapolating laboratory results to planetary scale without accounting for losses that dominate at those distances. His patents on wireless transmission, filed from 1897 through 1914, contain principles that underlie modern radio, remote control, and resonant power transfer. The United States Supreme Court ruled in 1943, shortly after Tesla's death in January that year, that Marconi's radio patents infringed on Tesla's earlier work. Patent 6.45576 specifically covers tuned circuits for wireless transmission. Patent 7.2318 covers logic gates for signaling systems. These are foundational technologies. Researchers studying extremely low-frequency propagation through the Earth ionosphere cavity reference Tesla's work. His experiments provide historical data points about electromagnetic phenomena before modern instrumentation existed. The Colorado Springs notes, published 78 years after he wrote them, remain valuable documentation of early radio frequency engineering. Visiv Technologies in Milford, Texas built a facility with a 300-foot tower attempting to demonstrate global power transmission using Tesla's principles. They claim to use surface wave propagation, essentially ground currents at specific frequencies. As of recent reports, they've demonstrated some transmission capability at short ranges, but nothing approaching global distribution. The physics still limits practical application. Other groups examine whether quantum effects, zero-point energy, or other exotic physics might enable what classical electromagnetics says is impossible. No breakthroughs have emerged that overcome the fundamental loss mechanisms. Tesla understood electromagnetic resonance at a level far beyond his contemporaries. His intuition about planetary scale electrical phenomena was largely correct, even when his calculations were approximate. He pioneered experimental techniques that influenced all subsequent radio engineering. His vision of wireless power inspired generations of researchers who've developed practical short-range systems using related but distinct physical principles. His business failures stemmed not from bad science, but from attempting to commercialize technology for which neither the supporting infrastructure nor the economic framework existed. Morgan withdrew funding, not because the physics was impossible, but because the pathway to profit was unclear. Tesla poured his own fortune into Wardenclyffe because he believed global wireless power would benefit humanity. The market wanted systems you could meter and monetize. He moved into the Hotel New Yorker in Manhattan, room 3327, fed pigeons from his window, maintained eccentric habits, claimed to be working on a particle beam weapon, the death ray, in the 1930s, tried to interest governments in defensive weapons, got $25,000 from the Soviet Union in 1939 to investigate beam weapons, but the project went nowhere, never married, died alone. January 7th, 1943, 86 years old. The FBI seized his papers immediately under wartime security protocols. His personal effects and technical documents eventually were shipped to Belgrade, where the Nikola Tesla Museum holds the archive. Roughly 60,000 documents, lab notes, patent drawings, correspondence, photographs. This archive, particularly the Colorado Springs notes and Wardenclyffe correspondence, provides the factual basis for understanding what he actually attempted versus what myth attributes to him. Tesla calculated that by using Earth's diameter and the speed of light, the quarter wavelength for global transmission would be about 6,500 kilometers. The fundamental resonance would occur when the wavelength equals the circumference of Earth. He designed Wardenclyffe to operate at frequencies that would establish standing waves under these conditions. The shaft depth, the antenna height, the cupola dimensions, everything calculated to maximize coupling into the Earth ionosphere system at specific frequencies. Patent documents show he planned for multiple towers spaced around the globe. Each tower would inject energy into the standing wave pattern, maintaining the global field. Receivers would extract power locally without significantly disrupting the overall field distribution. In principle, it's an elegant system. In practice, ohmic losses, atmospheric variations, interference from lightning, solar activity affecting the ionosphere, and the inverse square law for receivers not positioned at optimal nodes all combine to make it unworkable at planetary scale with 19th and early 20th century technology. Could it work with 21st century technology? Probably not for global power distribution. The losses remain prohibitive. The interference issues intensify as we have far more radio frequency devices now. But for certain applications, high-power, extremely low-frequency transmission could potentially send energy over hundreds of kilometers through the Earth or ocean. Military researchers have examined this for submarine communication and remote sensor networks. The systems remain expensive and inefficient compared to alternatives. Modern wireless charging systems, RFID tags, contactless payment cards, wireless vehicle charging, implantable medical device charging, all use resonant coupling at higher frequencies than Tesla employed, but following the same principle. Two circuits tuned to the same frequency exchange energy efficiently through electromagnetic fields. Tesla's patents from the 1890s describe this in detail. The world wireless system he envisioned, simultaneously transmitting power and information globally, resembles the internet and cellular networks from an information standpoint, and wireless power networks from an energy standpoint. He imagined portable devices receiving both power and data wirelessly over a century before smartphones. He described remote control systems where a device responds to wireless signals to perform actions, exactly like modern remote controls, drones, and IoT devices. The vision was prophetic, even when the specific implementation path was impractical. In 2012, the Tesla Science Center at Wardenclyffe launched a crowdfunding campaign with internet cartoonist Matthew Inman, the Oatmeal. They raised $1.37 million. In May 2013, they purchased the 16-acre property, including the laboratory building and original tower foundation. It's now a historic site. American Physical Society designated it an APS historic site on December 11, 2016. The citation recognizes Tesla's critical role in alternating current motors, power grids, and his pioneering wireless communication work at Wardenclyffe. The tunnel system and earth grippers documented by Cipher remain largely unexplored. Ground-penetrating radar suggests extensive underground infrastructure exists beyond what historical documents describe. If fully excavated, these could provide additional insight into Tesla's coupling system design, permits, and funding limit progress. 108 years after Colorado Springs, DARPA demonstrates power beaming over 5 miles with lasers. 124 years after Wardenclyffe's construction began, commercial electric vehicles charge wirelessly using resonant coupling. The specific methods differ from Tesla's plan. The physics involves higher frequencies, shorter ranges, and directed rather than broadcast transmission. But the underlying insight that resonant systems can transfer energy efficiently through space has proven absolutely correct. Modern physics confirms the Schumann resonance at 7.83 Hz with harmonics at approximately 14, 21, 27, 33 Hz. Measurements show this resonance varies slightly with solar activity, season, and time of day. Exactly as you'd expect from a cavity whose upper boundary, the ionosphere, changes height with solar illumination. The quality factor measurements confirm substantial damping, explaining why Tesla's global power system couldn't overcome losses. Lightning generates the energy that maintains these resonances, pumping roughly 1,000 strikes per second worldwide into the Earth ionosphere cavity. This natural excitation maintains the background Schumann signal that some researchers study for potential biological effects. Modern research into longitudinal electromagnetic waves, evanescent waves, and near-field effects shows phenomena that partially match his descriptions. Whether these represent distinct physical effects or merely aspects of conventional electromagnetics viewed from different perspectives remains debated. No experimental evidence supports Tesla extracting useful energy from exotic electromagnetic effects that violate conservation laws. His actual systems used conventional, if highly optimized, electromagnetic coupling. This appears in Modern Mechanics and Inventions magazine, July 1934. The drawing shows a Type 2 transmitter configuration with 2 properly spaced top-loaded helical resonators. This suggests Tesla continued refining his wireless power concepts decades after Wardenclyffe failed, moving toward paired resonator systems that would later prove more practical than single tower configurations. The MIT Witricity work uses paired resonators. Tesla anticipated this architecture. The most genius aspect of Tesla's wireless power understanding wasn't the specific hardware. It was recognizing that energy transfer is fundamentally about impedance matching and resonance in electromagnetic systems. Whether you're coupling to the Earth, to the atmosphere, to a nearby coil, or to free space, efficiency depends on how well the transmitter and receiver match resonant frequencies and couple their fields. This principle applies at any frequency and any distance. Modern wireless power systems succeed by optimizing this matching for specific applications, rather than trying to solve the universal case Tesla attempted. His vision of a wireless-powered world inspired technological development that continues today. Where he failed was in attempting to deploy planetary-scale infrastructure before the supporting technologies, materials, regulatory frameworks, and economic systems existed to make it viable. The gap between laboratory demonstration and commercial deployment proved unbridgeable in his lifetime. In 2024, a Tesla technical research paper by Krishna Mohanavansha, published through SSRN in December, re-examines Wardenclyffe tower design and the resonance-based high-frequency electromagnetic wave systems Tesla proposed. Multiple research teams continue studying Tesla's original notebooks, looking for overlooked insights. The Nikola Tesla Museum in Belgrade maintains the archive and regularly digitizes more material. Researchers in fields from power transmission to lightning physics to atmospheric science reference Tesla's work, because his experimental data from 1899 through 1905 captures electromagnetic phenomena at power levels and frequencies rarely studied since. Here's what we know Tesla understood about wireless power that makes him genius rather than simply visionary. 1. Planetary electrical resonance exists and can be measured. He predicted this before instruments existed to confirm it. 2. Resonant coupling allows efficient energy transfer between systems that would otherwise couple weakly. Modern wireless charging proves this daily. 3. The Earth ionosphere cavity functions as a waveguide for extremely low-frequency electromagnetic energy. Lightning research and Schumann resonance studies confirm this. 4. Precise tuning and impedance matching determine whether wireless power systems succeed or fail. Every radio engineer learns this principle. 5. Scaling laboratory results to global systems requires accounting for losses that dominate at large scales. This is where his practical implementation fell short, but he understood the requirement. Tesla's wireless power patents describe tune transformers, resonant circuits, ground coupling systems, elevated capacitance structures, frequency selective receivers, and methods for multiplexing power and data transmission. These patents, issued between 1897 and 1914, form prior art for essentially every subsequent wireless power technology. Companies licensing modern wireless charging technology trace their intellectual property lineage back to Tesla's foundational work, whether they acknowledge it or not. The foundation, where the 187-foot tower once reached skyward, remains. Below ground, the shaft extending 120 feet deep, and the network of tunnels and copper plates stay buried, a physical record of Tesla's attempt to grip the Earth electrically. No other facility demonstrates the same scale of ambition to couple human technology to planetary electromagnetic systems. When funding and technology finally allow full excavation, we'll learn more about exactly how Tesla designed the grounding system for resonant coupling to telluric currents. What separates Tesla from other inventors is this. He didn't just propose wireless power as a concept. He built hardware. He took measurements. He filed detailed patents. He documented experimental procedures. He calculated the planetary electrical parameters. He constructed a full-scale prototype facility. The technology didn't work as a practical global system, but the scientific understanding underlying it was substantially correct. Modern technology validates most of his physics, while revealing the practical limitations he couldn't overcome. The genius wasn't thinking power could move without wires. That's obvious once you see electromagnetic induction. The genius was understanding the Earth itself could participate as an active element in the transmission system. That the planet's resonant properties could be engineered into a power distribution network. That receivers anywhere on the surface could tap into a globally maintained standing wave pattern. That precise frequency control and impedance matching would determine system performance. These insights required understanding electromagnetic theory at a level few possessed in the 1890s. Tesla filed his wireless power patents in 1897, less than a decade after experimental confirmation that electromagnetic waves exist. He was working at the absolute frontier of physics, using equipment he mostly designed himself, making measurements that wouldn't be repeated for half a century. The Colorado Springs laboratory operated for 7 months. In that time, he generated more experimental data on high-voltage radio frequency electromagnetics than existed anywhere else. Those hours produced electromagnetic effects visible for 100 miles. What Tesla achieved in that brief test remains partly mysterious because he never published the results. We know witnesses saw spectacular displays. We know local electrical systems experienced interference. We know Tesla considered the demonstration successful enough that he saw no need to repeat it. What we don't know is whether he transmitted measurable power to a remote receiver or simply demonstrated the ability to perturb the local electromagnetic environment with sufficient intensity. Here's what no longer matters. Whether Tesla's specific Wardenclyffe tower configuration could have powered the world, clearly it couldn't with early 20th century technology. What matters is whether his understanding of resonant electromagnetic coupling, impedance matching, and planetary scale electrical phenomena was fundamentally correct. Modern physics says yes. The Schumann resonance exists at the frequency range Tesla calculated. Magnetic resonance wireless power works at short ranges exactly as Tesla's patents describe. ground conduction of extremely low-frequency energy propagates as he predicted. His theoretical framework was sound. Execution failed because the engineering challenges were insurmountable given available resources. A 200 kilowatt generator couldn't pump enough power into the Earth to maintain useful field strengths globally. The wooden tower structure couldn't handle the mechanical stresses of sustained high voltage operation. The control systems couldn't maintain the precise frequency stability needed for optimal resonance. The measurement equipment couldn't verify that remote receivers were actually capturing power efficiently. The financial model couldn't sustain development without demonstrable commercial returns. Each problem solvable in principle, but the combination exceeded what one inventor could achieve. Now we reach the late reveal that reframes everything. In a soil analysis at the Wardenclyffe site conducted in 2021 during preliminary excavation work, researchers found metallic anomalies at depths matching Tesla's documented 120-foot shaft. Ground-penetrating radar imaging shows a complex network of conductors extending radially from the central shaft, consistent with his described copper plate and iron rod system. The pattern suggests not just a random grounding scheme, but a carefully designed impedance matching network with conductor spacing that would create specific capacitive and inductive properties at extremely low frequencies. If Tesla truly engineered the underground structure to resonate with the Earth ionosphere cavity, then Wardenclyffe wasn't just a transmitter tower. It was a planetary scale coupling transformer buried in the ground. The tower was simply the visible antenna. The real engineering was invisible, locked in soil beneath Long Island. Every wireless charging pad today uses a similar principle on a tiny scale, precisely designed coil geometry to maximize magnetic coupling. Tesla designed it for a coil the size of a planet. We won't know what he actually built until they dig it up. The foundation still stands. The shaft still extends 120 feet down. The copper plates and iron rods still wait in darkness. A century-old impedance matching network designed to grip the Earth and make it ring.